So A, it says e to the I phi1, e to the I phi2 is equal to e to the I times phi1 plus phi2. Okay, so to prove an equation like this, the way that you should do it properly is you start with the left-hand side, or this is one way. Sometimes you're gonna have to start with both sides, and maybe do some scratch work, but then when you actually write it out, you should start with the left-hand side and make it equal to something. Okay, so we can write down what this is equal to. This is cosine of, so e to the I of phi1 is cosine phi1 plus I sine phi1. That's just the definition, right? And e to the I phi2 is just cosine phi2 plus I sine phi2. Okay, that's just the definition. So e to the, that's equal to that, that's equal to that. Okay, now we multiply this times this. So this is cosine phi1 cosine phi2. And then, so that's the first two. And then what I'm going to do is I'm going to multiply the last two together. Okay, and so this and this is going to be minus, because it's I squared. I squared is minus 1. So this is minus sine phi1 sine phi2. So that's how I get that. Okay, and that comes from that and that term. Okay, then we have the inside terms, the outside terms. So this times this is going to be, that's going to be multiplied by I. Okay, and so this is cosine phi1 sine phi2. And then the inside terms, this times this, is going to be cosine phi2 sine phi1. Now, I probably didn't write these in the optimal order. I probably should have, wait a minute, I did write. Oh yeah, I did write the cosines first here. Okay, so okay, so that's the expansion of everything. And this term right here, if you look at trigonometric identities, that is going to be the cosine of phi1 plus phi2. All this is just that. And then guess what this one is? All this.
Sine phi1 phi2.
Yes, sine of phi1 plus phi2. Okay, and this is by trig identities. Trigonometric identities. And so that's equal to, and then this is equal to the e to the I phi1 plus phi2. Okay, so notice the pattern, notice the way that I did it. I started with the left-hand side. I had it equal to something. Then that's equal to something else. And then that's equal to the other thing. And then that's equal to the right-hand side. Okay, so that's how you prove something is equal to something else. You might have to have more steps, or maybe you could do it in less steps, but that's basically how you got, that's the format I like to see. That's the easiest to, for people to follow. Okay. So, did you want to see another part to that?
No, thanks. That's good.
That's good. Okay, so that's kind of the pattern to follow and how to do that. The other ones are a bit easier. Except maybe f. F is the derivative. What's the derivatives in there for?
There's an example in the book. Let's have the F proof.
Of f? Oh, they proved f.
They
Oh,
prove
yeah,
it.
so don't worry. They proved f. I see. So you're good there. Okay, great. What other questions do you guys have?
Can I ask 11b? I don't know how to do it with negative numbers.
Okay, this one right here, 11b.
Yes.
Z to the fourth equals negative 16.
Mm-hmm.
Okay. Okay. So let's do this one right here. There might be enough space in the margin and between the margin and over here, I might be able to do it. Okay. So what you want to do is you want to write negative 16 in polar form. Okay, that's the first thing you want to do. And negative 16 is over here. So one way to write it would be to go like that, use that angle there. So that would be, and then the radius, this distance here is 16. So that's going to be 16 e to the I pi. But that's also, if you go all the way around once and then back to there, then it's going to be e to the 3 pi I. So that's 3 pi. And then also that 16 e to the 5 pi I. So if you add multiples of 2 pi, you get another, you get something that's the same. Okay, so since it's raised to the 4th power, I want to get 4 of these, like that. Okay, now the right-hand side, what you do with the right-hand side is you set z equal to r e to the I theta. Now, it's very important that r has to be positive. R must be positive. Because that's how the radius works. It could be 0, but 0, when you're this kind of problem, r being 0 is not going to happen. So don't worry about that part. Okay, so r has to be positive. Okay, so if you raise this to the 4th power, okay, that's going to be, so that's going to be z to the 4th is your left-hand side, right? So z to the 4th will be all this raised to the 4th power, and that's going to be r to the 4th e to the I to the 4i theta. And then what you do is you compare it with each of these. So if I take the first one, for example, okay, so this is z to the 4th equals negative 16. If I take the first form of negative 16, and that's this right here, I'm going to equate the r to the 4th equals 16, and I'm also going to equate the 4i theta equals e to the I pi. Now, if r is, you have the restriction that r is greater than 0, that means that r has to be 2. Okay, so r is going to be 2. R is going to be 2 for all 4 of these cases. And then equating these top parts, you get 4 theta equals pi. So that means that theta has to be pi over 4 for that one. R equal, so let me try to be a little bit organized here. So you have e to the 4th negative 16. So you can come up with 4 equations. So they're going to be r to the 4th e to the 4th I theta equals 16 e to the I pi. And that's also going to be 16 e to the 3 pi I. And it's going to be the same thing. I don't know where that came from. Equaling 16 e to the 5 pi I. And then it's the same thing being equal to 16 e to the 7 pi I. Okay, and this one, theta is going to be pi over 4. R is going to be 2 for all of them. Theta is going to be pi over 4, and this one, theta is going to be 3 pi over 4. This one, theta is going to be 5 pi over 4. And in this one, theta is going to be 7 pi over 4. Okay, so your 4 solutions are 2 e to the I pi over 4. That's the first one. Your second solution is going to be 2 e to the I, or 3 pi I over 4. Your third solution is going to be 2 e to the 5 pi I over 4. And then the last solution is going to be 2 e to the 7 pi I over 4. Okay, so those are going to be your 4 solutions. So one quick note is you're only going to do 4 of these, because if you do another one, let's say you go, so you can see the pattern is 1, 3, 5, 7. If you go 9 pi I over 4, well, 9 pi over 4 is just going around 1 full time and then coming back to here, to that angle. And that is the same as pi over 4. So this one would give you the same angle as that. So it doesn't give you a new number. But each of these 4 are different. Each of these 4 numbers is different than the other 3. Okay, so does that help with that then?
Yes, it helps. Thank you.
Sure, you're welcome. So what else? What other questions do you guys have?
Can you do number 23E?
Okay, 23. This one?
Yes.
Okay, so 23E. Okay, there's no space there, so let's go. Let's do it on a blank page over here. Okay, so that is, you want to sketch this graph right here. Values of Z in the complex plane such that the modulus of Z is equal to the modulus of Z plus 1. Okay, the easiest, so there's 2 ways you can do this. One of them is by setting, so remember there's 2 ways. You can set Z equal to X plus IY and then work it out that way. And then the other way is you can exploit some stuff. And let's do this way here. And so the modulus of Z is equal to the distance between Z and 0. Okay, so, and then the modulus of Z plus 1 is equal to the distance between Z and -1. Okay, so what you have is, if here's 0 right here, here's -1, and you're looking for all points where these 2 distances are the same, where the distance between Z and 0 and the distance between Z and -1 are equal to each other. Okay, so for example, here's a point right here. This point here at -1/2. this has the distance between z and 0 is 1/2. The distance between z and -1 is also 1/2. So those are equal. Can you think of other points where those distances are going to be equal?
The whole straight line, x equals to -1/2.
Yes. On this whole line, every single point on this line, the distance between there and there is the same as the distance between there and there. But if you come over here, let's say you have a point right there, that distance is going to be smaller than that distance. So that's not going to be in the set. So it's going to be that whole. So the answer, that's the sketch of it. And are we supposed to just sketch it, or are we supposed to? Yeah, we're supposed to just sketch it. So that's the sketch right there. And it's x equals -1/2. An equation would be the real part of z equals -1/2. That would be an equation for the line. Okay, the other way would be to do this, but this takes a lot longer. But you could argue this way. This is the same as, but let me do that just for clarity. So this is the same as saying that their squares are equal. Okay, and here if we have x plus iy, modulus squared equals that. So that's what those are. This is going to be x squared plus y squared. Remember, if it's squared, then it's just going to be the sum of the squares of those two. Okay, and this one has real part x plus 1. And the imaginary part is still y. So that's going to be that. Okay, and then this is going to cancel with that. And you're going to have x squared equals, and this becomes x squared plus 2x plus 1. The x squareds are going to cancel, and you're going to get 2x plus 1 equals 0, which goes to x equals -1/2, which is going to be this straight line here. Okay, so that's two ways to do that one. Let's see here. We have time for maybe one more question before we need to get on to the other stuff. Did you guys want to ask one more question?
Can I ask a hint for 11D?
11,
D.
what, D? This one? Oh, 11D. Okay. So let's take a look at this one right here, 11D. And let me see if we have any. Oh, there we go. Okay, so here we have z to the 6th minus c cubed minus 2 equals 0, right? Okay, this one is going to factor into this. So what the z cubed squared is z to the 6th. So z cubed times z cubed is z to the 6th. And if you make that a -2 and a +1, then that's going to factor that way. And so then if you set that equal to 0, you get z cubed equals -1. And over here, you get z cubed equals 2.